Alright, hello everyone and welcome to my talk about Rust. So, a little about me. So, as you might know, I'm a member of the group 0xA and I've been using Rust since the summer of 2020. While I was doing my Matura, I had plenty of spare time and I decided to rewrite some projects of mine in Rust. And I used Rust primarily for game cheats, and there I also wrote like Windows kernel drivers, a hypervisor for AMD. I also experimented with neural networks. I also wrote an obfuscator and some backend services with gRPC and REST. So what will we cover in this talk? We'll go over the history a little bit, then we'll also check out which companies are already using Rust and why. And then we look at why we actually need Rust. And after that, we take a look what makes Rust actually better compared to alternatives like C++ or C. And at the very end, we'll take a look at the general language design. Alright, let's get started. So here's a short timeline of Rust. It got started in 2006 as a personal project by Creighton Hoare, who was a Mozilla employee. And a few years later, Mozilla actually started sponsoring the project, and eventually they also started developing it and employing Rust developers. And in 2012, they had the first pre-alpha release. And at that time, they already worked on integrating Rust into Firefox as part of their Gecko engine, but more on that later on. And in 2015, they already had their first stable release. This means that they're actually supporting the standard library and are making sure that there's no changes in the standard library, so you can run your application from 2015 10 years later and it still works. And in 2021, the Rust Foundation was founded, and this foundation is really critical for the language itself because it makes sure that the language and framework developers actually get paid, because often it's just open source work which is often unpaid. And as part of the Rust Foundation, so many companies formed it, including Microsoft, Huawei, Google, Amazon, and a bunch of others. And maybe you also heard of the Stack Overflow developer survey, and Rust actually is the most loved language, and that for the last 6 years. So about 80 or 90% of the developers who have been using Rust want to continuously use Rust in the future again. Alright, so now we already know a short history of Rust. Now we can also look at companies that use it. So as I already mentioned, Amazon uses Rust. And they also employ Rust developers. And they use it for their cloud platform. For example, they implemented a few projects which are designed to host lightweight containers and spin them up very fast. Another example is Mozilla. They use it for the Gecko engine, as I already mentioned. Then there's also Discord. And they wrote a pretty good blog post about it, and they were using Go before. And if you look at the graph, the purple lines, I'm not sure if you can read it exactly, but there's a few spikes every few milliseconds or minutes, and that's the garbage collector of Go. And in Rust, there is no garbage collector. So in Rust, it's basically a flat line. And Discord has millions or billions of customers and users, and having a spike like this is really, it's a mess, and it messes everything up. So they decided to switch to Rust. And yeah, obligatory meme. So maybe you've also read the headlines of the Linux kernel. They're actually deciding to add Rust as a language to the kernel. And this is big news because there's also C++ and a successor of C. But actually they decided against using C++ in the kernel because they thought it would add too much bloat. But they actually want to add Rust. Another example is Dropbox. Believe it or not, the actual sync engine was written in Python beforehand, and it was just messy and they decided to rewrite it in Rust. And Android also uses Rust. For example, they rewrote the Bluetooth kernel module in Rust instead of choosing C or C++. If you're using Postgres, there's a high chance you already interacted with some Rust services, as they're also using Rust instead of C++. And there's many others: Microsoft, Facebook, Cloudflare, and I'm pretty sure you know some of the names there. So now that we know companies are actually using Rust in production, let's take a look why we actually need it. And this is a graph from Microsoft. And it shows the CVEs they have, so in Windows. And if you look at the line, about 70% of all the security vulnerabilities are actually due to memory safety. So like buffer overflows, or forgetting to free something, or freeing something and then accessing it again. So that's 70% of all bugs. And the rest, the other 30, are just non-memory safety, for example, logical bugs or something. But that's already quite a lot. And yeah, and with Rust, we can basically take those memory safety errors and get rid of them. Because the Rust compiler, we'll get to that later, already ensures that these memory safety bugs cannot happen at compile time. Yeah. So let's take a look what makes Rust better. And these are like the keywords that the Rust marketing team tells us. So it's performance, reliability, and productivity. So you can still be as performant when choosing Rust over C++, even though the compiler makes sure that there's no bugs at compile time. And yeah, it's also reliable, there aren't any bugs, and you can still be productive. And this is also a pretty interesting paper from 2017, and they decided to take a look at the energy, time, and memory ratio of languages. And if you look closely, Rust is always pretty at the top. So if you write Rust, you're not even preventing bugs, you're also saving the planet, because your program doesn't use as much energy as others. And Rust also has static type system. So if you, for example, use Ruby, Ruby has dynamic typing, or like JavaScript. And if you write code, you'll see the error at runtime. And in Rust, when you compile it, you already get a nice error message and you can change it. So you can't actually ship imperfect code to the client. And there's a bunch of other things. Rust is pretty new, it's like over 10 years old. And there's a lot of modern approaches to tools, libraries, and the general thinking. And the community is also really awesome. They're really inclusive, and they want to make sure that Rust actually grows and reaches more people. They also use the LLVM compiler, which is a separate project independent from Rust, which makes sure that Rust programs actually are really fast. And for example, Go decided to write their own compiler, but that just adds a bunch of work. And Rust decided to use LLVM because it's already very established, and you can also choose this backend for C++ or C. And Rust is also open source, which is really nice because you can then also contribute to the source. So now that we know what makes Rust better, we can take a look at how Rust prevents security vulnerabilities. And there's 3 core features used for that. So one is borrowing, the other is ownership, and the last one is lifetimes. So borrowing just means you can get a reference and you can borrow, in this case, the book for a certain period of time. But if you think about it, there can only be ever one mutable borrower. For example, if I give you the book and you decide to write something in it at a certain place, another person can't write at the same place at the same time. That's a race condition, as we already learned in the operating systems class. But you can still have many different people read the book at the same time. And so here we see 2 people try to write into the book at the same time. And if we try to compile this program, the compiler instantly complains. So it says the first mutable borrower occurs here, and then the second mutable borrower occurs here. And the compiler already tells us what's wrong. We have 2 mutable borrowers. Yeah. So the next important concept is ownership. So if we add a function burn, which gets rid of the book, it just deletes it, then this function takes ownership of the book. So book is essentially moved into this function and it's gone. Then the main function can't access it anymore. So if somebody tries to borrow the book again, the compiler will also complain because the value has been moved. So this is also really important that the compiler already detects that. And the last concept is a little more complicated. It's about lifetimes. So when we are looking at the code, we can see we create the book at the very top. So when the function exits, the book is also destroyed. It's gone. It's not there anymore. Nobody can access it anymore. But if we now create a new block, this could also be a new function, we can borrow the book. And the borrower lives for exactly this block until it exits again. And because of that, the Rust compiler can make sure that we can't have mutable references to, for example, the book in this case. Yeah. So we now introduced a few concepts and they might seem a little complicated. And you might now ask, but why do we actually need them? So let's take a look at a few security vulnerabilities. So can anyone spot the issue here? So we are allocating memory and then we are assigning a few characters. Oh, this shouldn't work. Yeah, whatever. So actually we are not freeing the memory. It might not be as critical because when main exits, it's already deallocated. But if this is just a regular function, we should deallocate it. So we are leaking memory, and we obviously don't want that. And in Rust, with ownership, this doesn't happen. Whenever an object is created and it goes out of scope, it's automatically deallocated. Thus, we don't need a garbage collector. So here's another example. What if we actually free the memory, but then we access it again? This shouldn't happen. And with Rust, we also can prevent it with ownership. As you saw before, if we burn the book or free the memory, you can't access it anymore. And if you have a more complicated example, like Fibonacci with some dynamically allocated memory, it's not as easy anymore to spot a bug by looking at the code. And I'm sure we could look at the code for quite some time now and check if there's some security vulnerabilities, and we could still not be sure. And do you think there's a vulnerability in this code? I'll just let you read through it. some time. So, I mean, maybe one of you can find one, but actually there isn't any, there's no vulnerability in this code, but it looks pretty complicated and you can't really see what it's doing. So this is the reason why it's very important that the compiler automatically checks these issues for us, because the compiler is much smarter and we should rely on the compiler. So in summary, the compiler checks all these things at compile time. So you don't even have to run the program to know that it should crash at compile time. And this means that you have more compiler errors at runtime, at compile time, and thus fewer crashes at the runtime. Yeah, and so if you're C++, you should be pretty worried. Or yeah. C++ developers be like it. Yeah. Alright. So now we know the important concept of Rust. We can take a look at some useful tools you need when developing Rust. And the first one is RustUp. It's essentially the package manager, and it's really easy to install toolchains. And you can think of toolchains as certain computers you want to target. You could write programs for your Raspberry Pi, then you need to target ARM. Or for Windows, you need to use Windows MSVC. For Linux, you can use GNU. And there's also a concept called channels. Because in Rust, there's stable, which means, how should I explain it? So in stable, you can be sure that everything works as expected and there's no bugs. But in nightly, you can actually access features that are currently in development and test them out. Often they're already pretty stable, but there might be some crashes from time to time. And with RustUp, you can also install additional components like Cargo, which is also a really important tool. We'll come to that later, and Rust format. Yeah. So Cargo is the package manager, and Cargo essentially makes sure that it automatically pulls the packages and it builds a project and invokes the compiler. And if you want to create a new project, you can just call cargo new --bin and then the name of the project. So here we are creating a new project called Hello World, and it's a binary project, so we can actually run it. And now we can look at the cargo.toml, which is basically the same as a package.json for those that already worked with Node.js. And in there we have some metadata like the name, version, and edition. And then we can also specify the dependencies. Yeah, and if we want to run it, we can just type cargo run, and it already works. We don't have to set up CMake or some linker paths. It just works. So when you are developing applications, you don't want to implement everything by yourself. That's why crates or packages are really important. And in Cargo, that's crates.io. And there you can search for packages that you want to use. For example, if we want to generate random numbers, we could use rand, which is really popular. And all you have to do, you have to copy the rand equals and then the version number and add it to the crates.toml. And that's it. You don't need to do more. Yeah. So, and compared to C++, this is a huge advantage. If anyone ever worked with C++, in C++ you don't really have a single package manager. The CMake, VC package, Conan, but it's still a mess and really complicated to set up, especially if you're targeting specific platforms, or yeah, it's just a mess. And yeah, in Rust it's really easy. So now that we actually pulled the rand dependency, we need to figure out how we can actually use it. And Rust also has a website which already automatically generates the documentation for every Rust project. And we can access that. And as you can see, the developers of this library already made some really helpful examples. So we can see that we could write rand : random, and we get a random number. And this makes the entire development workflow much more pleasant. Yeah. And if you're already a Rust developer, I can highly recommend the Rust search extension, which really speeds up the development workflow. You can basically type in the URL bar and find whatever you want within seconds. Yeah. And a Rust format is essentially the formatter for Rust. There's a few examples in other languages, like in JavaScript there's Prettier or ESLint, but there you already have many options. And in Rust there's only one Rust format. And this makes sure that every Rust code looks exactly the same. You can still configure it, like the line size or some other options, but in general the code pretty much looks always the same. And there's also another project which is really cool. It's called Clippy. And there you have over 500 lints. And basically they make sure that your code is actually idiomatic. And they detect common issues and they show it to you. Yeah, and there's like different groups for that. And I'm not sure if you can read that, but here's an example, and basically it's for trim whitespaces. And basically when you have a string, use like a whitespace A, whitespace B, whitespace C, whitespace, and then a dot trim and dot split whitespace. Clippy already knows that you don't need the dot trim because the dot split whitespace already handles that. And Clippy is really useful if you're just starting out and learning Rust, because Clippy shows you how you could improve your code. And it's all done automatically. Yeah, there's another example, but I think we can skip it. Yeah. And error messages. So Rust has a really powerful compiler. This means you get many error messages. And because of that, you want to make sure that they're actually good and not like in C++ or something. So if you have a typo in your code, the Rust compiler already automatically suggests a fix. For example, I misspelled book in this case, and it already suggested the fix. Or if I forget an import, it already shows this to me. Or if somebody tries to add a Greek semicolon to my code, the Rust compiler also checks for that and shows it to me. Yes. Yeah, and as you maybe saw, the Rust compiler also has colors. And this is also really cool, because you literally see at the first second what's wrong and what you should do. And yeah, this might be a C++ error for a missing asterisk. And if you didn't know, there's actually a challenge to create the longest C++ error message, and they even had to forbid templates, because yeah, templates are just a mess and they're known to create huge error messages. So now we can take a look at the language design. And Rust is actually really interesting because they decided against having the parentheses around the if condition. And yeah, so we can create variables with let, and the types are already automatically inferred. So because we are assigning a boolean, condition is also a boolean. And then we can just print something to the console. We also have loops in Rust, but they're a little different. There are no for let I equals 0, then I smaller than I++. In Rust, we only really have a for each. So we can create an array of elements and then iterate over them. Yeah, and again, there's no parentheses. And we can print them, and here we have a special syntax, and this just makes sure that the element is actually placed there. So there's no format strings in Rust, no percent %u or something, or %d. It's just the angled bracket. Yes.
So does that mean that you always have to use for each? If you want to, for example, find out like the middle part of an array, what is written in there?
I'll come to. So in Rust is also the indexing. So with the angle, and Rust also has ranges. I'll show it here. Yeah. So you can use ranges for arrays, and then say you only want the elements from 1 to 5. Yeah. Yeah. So.
What if you're like searching for the index of a special word? Can you return the index?
Yeah, that's possible. But here you have the range, and there's a special API call in Rust that's called .enumerate, and so if this were a list of names or something, and you want the index, you could write elements iter for iterate, and then enumerate, and this returns a tuple. The first item is the index, and the second one is the element. And yeah, we'll come to tuples later. Yeah. So yeah, here we are just printing the elements from 1 to 5, and we can do the same by just having a range. And this is really powerful because yeah, it's much simpler. Yeah. So now we have tuples. So if you call a function, you can return multiple values. And this is not an array, but it's a tuple. And here we return 1 and 2. And when we call the function, we can either assign it to a variable, and then we can access it with the indices, so 0 and 1, or we can also automatically destructure it, basically kind of like in JavaScript, where you can also do that. So when we call foo, we are actually already assigning the value 1 to A and 2 to B, and then we can print that again. So if we go back to the for loop, we could write so if this is the enumerate function, it could return the index and the element, and we could do exactly this in the loop as well. Yeah. And in Rust, a really important feature is the option enum. It's basically like the optional from Java. And in Rust, it's defined like this. It's really simple. It's generic over some type, and you can either have nothing or something of this type. And what this allows you to do, basically, if you have a function, and then you can have some condition that might cause the function to fail, then you return none or either some. And yeah, so I probably should mention in Rust, you don't need the return statement, because everything is an expression. So if you don't have the semicolon at the end, it's always returned in a block. So the block starts here, and it's returned to foo. And the same for the if condition. So the function returns an option or that with a number. And then we can assign it to the variable again. But we actually need to get the value, if there is a value, out of it. And we can do that with the unwrap, but it's generally not recommended because when you unwrap an option, it just either gives you the value, or if it's none, it crashes the program, and you don't want that. And an alternative is expect, which also crashes the program, but at least it shows a nice error message, what's wrong. But if you don't want to do that, you can actually destructure it again. And this is also really powerful, because now you can have an if condition, and only if the option was successful, we can get the number again, and we can print it to the console again. Yeah. And so when unwrapping, we then had the number there. But when we are using the if let number, we can't do that. Then we can only access it in the if body. So we could also check if the option was sum, so if it actually contained a value, and then return the number, or have some default value. Yeah. Or a new addition in Rust, which is not yet on stable Rust, is the else branch. Yeah. So it might look a little weird at the first sight, but it's actually really cool because it allows you to write your programs much easier, and it makes it much cleaner. Yeah. And we also have results, which basically get rid of exceptions. Because there you either have a value with some type T or an error of type E, and then you can pass specific errors as well.
So does that mean if we want to catch some exceptions that Rust hasn't checked out by compiling, we always have to use the result, since there is no try catch and no exception handling in the additional way?
Yeah, kind of. So yeah, there's actually only result, and they rely on the type system. So you have to catch all errors. Otherwise, the compiler complains and your program won't compile. Yeah. And the unwrapped exceptions are a little special. They're called panics, and you can catch those, but it's generally not recommended. Panics are really only for cases where your program shouldn't continue. And errors are in general.
So should I think of it like null pointers and subject exceptions from Java that I generally don't need to catch, but if they occur, it's really bad.
Yeah. Okay. Yeah. And in Rust, there's no switch cases, but it's called match. And there again, we have pattern matching. So we can assign the result with an OK value, and we then have the problem again that the value 42 is actually inside the result enum, and we need to access it. And with the destructuring, we can check if the result is okay, then we get the value, or if there was an error, we can actually get the error, and we can print both to the console again. Yes.
If I don't write down the error branch, do I get a compile error?
Yes.
Okay. So exhaustive pattern matching is required.
Yep. You can circumvent it by using the underscore, which is like a wildcard for any other case.
Yes, of course, but
but
some branch has to be executed.
Yep.
Yes,
exactly.
Can you also destructure within the value itself? So can you say OK of 0, OK of 1, and OK of value if it's something else? Oh,
yeah, cool. You can do that. and everything is an expression in Rust. So if you have a function, we already learned that there's no return statement. So this function just returns 1. And then we have a variable, let value, and it equals to a block, and it closes here. In there, it's basically, you can think of it like a function. You have a variable again, it's local, and then we have an if, and this if also returns a value again. So if the sum condition is met, we return a plus 1, so 43, or else we just return the value of foo. And yeah. So we looked at the language design, and now we can actually look at a few examples how you can do certain things in specific languages. So can anyone tell me how you could deserialize or serialize data, for example in JSON, XML, TOML, YAML, in any language, Java, Node.js, C#?
In Node.js there's a JSON package. You can call to JSON and it returns string.
Yeah, exactly. So in Rust, there's actually something similar. There's a grid called Soda, and you can implement serialize and deserialize for any structure. So here we have a context structure, and it has a vector of integers for foo and another integer for bar. And if we want to serialize it, we can create this structure, and you just need to call this function, so the JSON : to string, and then you already have the JSON string. And it's the same for deserializing. You can just call so the JSON from string, and you get the struct back. And this is for JSON. So if you want to switch to XML, it's exactly the same. We still have the Serde, so we still have this. And the cool thing in Rust is, in the ecosystem, everyone relies on this. So this is the same for every crate that you use. So this makes it possible to switch out the actual format that you're serializing to. So we could now replace it to XML or even TOML or YAML. And how would you pass CLI arguments in other languages?
The arguments in main.
Yeah, but so you could do it manually, but it's kind of a. And in Rust, there's actually a library that makes sure that makes it easy for you. So it's called struct_opt, and you can basically define your structure and all the options. And here we have a comment, we'll get back to that later, and then we just do something there again. And in there, we can define all the different options. We have a comment, and then we specify it should have a short abbreviation and a long argument for debugging. Or you can even specify values, verbose, or speed. You can also specify a path and a bunch of other things. It's really powerful. And then in the main, you can just call opt from args, and it automatically returns the option with all the command line arguments. And if you run the program now without any arguments, it automatically shows you this error. And this is automatically generated, and you don't have to write that yourself. We only wrote this struct, and the rest is automatically generated. And we can even then pass show the help page. And if you remember correctly, the activate debug mode was actually a comment in there. So if we check it out, so activate debug mode, this is automatically shown on the command line. And this is really cool, because then you don't have to implement the command line parsing and making sure everything works and making sure the path is correct. You don't have to implement everything yourself. You can rely on this trait. Yeah. Alright, so we already covered a lot. How can you get started? So in Rust, we have the book. It's a Rust book, and it's really good. And it basically gets you started. It introduces you to all the concepts, and I can really recommend reading it in advance. If you want to be up to date on the latest traits or some blog posts or news articles, I can recommend the This Week in Rust newsletter or the Rust subreddit. And there's also Exercism, which is really cool. There you can implement some algorithms in Rust and also other languages. And I like to learn new languages by just writing projects. So maybe just start rewriting or writing new projects with Rust. Or maybe if you don't get started yourself, somebody will motivate you.
No.
Alright, thank you for your attention.
Final question.
Yes?
What do you hate about Rust?
The compile times are kind of long on the first run, but it's really cool because they're also really transparent about it. And you can see in the This Week in Rust newsletter, they're showing the regression and improvements every week. And it's really cool to see how the compile time evolves. Yep.
Is there like a learning platform where you can try it out? It's like Write Up?
Yep. There actually is. And just one moment. So there's a Rust playground, and it's really cool because so you can go to the Rust playground and just enter your program, print line hello world or print line hi. And when we run it, it just works. Yeah, there you go. But there's also others, but this is the main one that's most often used.
Does this use WebAssembly to compile this, or how does this work?
Actually not sure. I think it uses containers in the background. Yeah.
And another question about the term lint. What does it mean? You use this.
So lint basically is
maybe in context of Clippy.
Yeah. So Clippy basically analyzes your code and it shows suggestions what you can fix. So that's generally called a lint. So in your code, if you, for example, in IntelliJ, when IntelliJ also shows some lints that you can improve. For example, if you have a variable that's created and then you instantly return it, IntelliJ already complains that it can be inlined. That would also be a lint.
Yeah. It's typically about things like tabs versus spaces and indentation depth and things like that, because the muscle memory might tell different developers on a team different styles, and the linter then automatically formats it in a specific way, for example.
Yeah. Any other questions?
Are there game engines for Rust?
Yep, there are quite a few. A popular one is called Babby. Yeah, this one. And it's really popular. You can even check out the documentation. You can run it in the browser. It's really cool and also really popular. But there's a bunch of other ones that you can also use. You can even use it with Godot. Yeah. Alright.
Is there a object type, like in C# there is the object, for the object type which implies that you can use a string, int and so on. Is there something like that in Rust?
Wait. What's that used for?
Basically you can put anything you want in there.
Oh, so like in Java object.
Yeah, like a variable.
Rust actually isn't object oriented. So in Rust you only have structures.
So that means if you have a request from another service which provides data, like for example it can provide strings and integers, that means that Rust always and only always gets the string or the integer, and that's why there cannot be a runtime exception.
Exactly, it's part of the type system.
There's, as far as I've understood, there's type polymorphism in Rust, so you can have a list of a polymorphic element type or something like that, but at compile time all types are known for specific thing. And the only type of inheritance that it has is interface inheritance.
Yeah, so in Rust they're called traits.
Yeah, sure.
Yeah, exactly. Alright, good attention.